All right, Maxim team, let's get right into it. Today, we are taking total control of the DTF, or direct-to-frac system. Think of this explainer as your ultimate field guide. We're going to take you straight from hooking up that very first cable all the way through to running flawless, automated frac stages. We are taking that dense technical manual and turning it into clear, actionable mastery. So, let's dive in. Here's our roadmap for today. We'll be hitting 1. System connection and integration, 2. Calibration and safety rules, 3. Autopilot and silo setup, 4. Dynamic silo swapping, and 5. Master the control panels.
Starting right off with Section 1, System Connection and Integration.
First things first, you've got to physically hook up the data cable directly from the blender to the DTF control box. What you are looking for here is a green indicator that says EVO connected. If you see EVO error COM, stop right there. You've got a network issue that you need to troubleshoot before moving on. Next up, the data van crew has to confirm they're actually receiving telemetry, things like clean rate or sand concentration. Finally, set the Baby Beast switch to manual at exactly 365 feet per minute. Why that specific number? Well, that exact speed guarantees a perfect mechanical handshake with the main conveyor belt's flow.
Now, before we go a single step further, listen to this absolutely critical safety rule. When you're running these initial communication tests, you must ensure at least one of the initial values from the data van is set to 0. This is a strict, non-negotiable safeguard. We literally do not want an accidental, uncontrolled avalanche of sand just because you were trying to ping the network. Safety first, always.
Okay, so to hand the reins over to the DTF system, you can't just tap a button on a screen. The system requires a physical hardware interlock. You actually have to walk over and turn the selector switch on the base from manual to automatic. If you leave it in manual, the blender is completely locked out of the gates. Once you've physically switched it, hop over to your HMI screen and hit Enable DTF until it glows yellow. Boom, now the system is listening to you.
Moving right along to Section 2, Calibration and Safety Rules.
I want you to look at the sheer precision required here. On the DTF info screen, the set open time and set close time are measured in pure milliseconds. These tiny numbers dictate the exact split second the hydraulic cylinders drive those heavy gates. So before you even think about activating autopilot, it is absolutely essential to verify these parameters. But notice I said verify, not adjust.
Actually, let's make this a golden rule for the whole crew. Do not modify those time parameters. They are pre-calibrated for optimal fluid conditions. If you notice a piston is acting a bit sluggish, whatever you do, do not put a digital band-aid on it by altering those milliseconds. If you tweak those, you alter all 3 silos and completely destroy the precision of your entire stage. Instead, grab your tools and perform the mechanical maintenance. Fix the hardware, do not mess with the code.
All right, let's get into the really good stuff. Section 3, Autopilot and Silo Setup.
Your HMI pulls a real-time data feed straight from the Cedar system. Think of this as your ultimate inventory command center. With just a quick glance, you're tracking the mesh type, the live weight, and the exact aperture of the hydraulic gates, down to the millisecond, across all 3 silos. Just to give you an intuitive grasp of the massive scale we are dealing with out here, when that screen says a silo is at 100% capacity, you are looking at 500,000 pounds of sand. Let that sink in. And 100% gate aperture, that means that hydraulic gate is physically yawning 20 inches wide. Keep those massive, real-world physical benchmarks in your head as you're watching the digital numbers tick by. Now, when autopilot is running, you might get tempted to intervene. Don't do it. Manual override acts exactly like slamming the brakes while your truck is locked in cruise control. If you touch those manual levers, autopilot instantly disengages. And worse, any sand you discharge manually isn't going to be deducted from your global stage goal. Remember, only the sand delivered while actively in autopilot actually counts.
Which brings us to Section 4, Dynamic Silo Swapping. This feature is an absolute game changer for continuous flow. You just tell the system which silo to drain first and which one to automatically jump to when that first one runs dry. But hey, consider this a massive operational warning. The system does not auto-validate mesh compatibility. It is going to blindly swap to whatever silo number you input. You have to independently verify that your backup silo holds the exact same sand type before you set this up.
Let's look at a practical math scenario so you can see just how seamless this really is. Say your stage requires 450,000 pounds of 100 mesh sand. Silo 1 only has 300,000 pounds, but Silo 2 also has 300,000 pounds of that exact same mesh. All you do is set Start Silo to 1 and next silo to 2. The DTF will flawlessly dose the first 300,000 pounds from silo 1, automatically swap over to silo 2 without missing a beat, dose the remaining 150,000 pounds, and then independently close the gates to end the stage. It's beautiful.
Here is a quick operational pro tip for you. The automatic system uses an optical scale, which is highly precise, rather than your conventional load cells. Because of that extreme precision, you might notice a visual variance of maybe 2 to 3% lower than you'd expect. So, if you're 9,000 to 15,000 pounds under what you think you should be seeing visually, do not panic. Trust the optical scale. It's giving you the true accurate reading.
And finally, Section 5. Master the control panels.
42. No, it's not just the answer to the universe. It's the golden formula powering your entire demand logic. To calculate the target flow rate, the system takes the clean rate, multiplies it by the sand concentration, and then multiplies that by 42. That final number you get, that is your exact target pounds per minute.
Now, as the DTF chases that target flow rate, it's working with a 5% operational tolerance. Keep your eyes on the C, O, and R indicators. If C turns green, your flow has exceeded plus 5% and the system is actively commanding the gate to close. If O turns green, the flow is too low and the gate opens. But if you see an R, that means range. You are perfectly in the sweet spot and the system is holding completely steady.
Let's rapid fire through the essential HMI buttons you'll be using. Run DTF starts your autopilot. Stop instantly kills it. Get data starts the accumulator. And keep in mind, every 0.1 cubic meters equals 1 pulse, or roughly 394 pounds of sand. And finally, clear data. You must press this after every single stage to reset the PLC back to 0. It is an absolute, non-negotiable step for keeping your inventory control accurate.
Maxim team, you now have the complete blueprint. You know how to secure the hardware, you know how to enforce the safety interlocks, program the automation, and read the telemetry like an absolute expert. This system is capable of incredible, continuous precision, but only if you respect its parameters and trust the automation to do its job. You've got the knowledge now. So the only question left is, are you ready to step onto the pad and let the DTF completely transform the way you run a stage? Thanks for hanging out with me for this explainer. Stay safe out there, and let's get to work.